Hello everyone, welcome to SwitiSpeaksOfficial YouTube channel. This is System Verilog trick code series where we are going to see some trick codes in System Verilog. For this, you need to go through the System Verilog concepts. A lot of videos on System Verilog concepts I have already uploaded. There are different series. For example, I have started System Verilog tutorial series in which we have covered all the data types. Then we have System Verilog Essential series in which we have covered concepts like System Verilog region, program block, clocking block, all those things which people find it difficult to understand, but we have tried to cover all those in simple and easy language along with coding examples in System Verilog Essential series. Then we have started the series for System Verilog OOPS, System Verilog assertions. So please go through all these series because once your concepts are clear, once you practice some System Verilog codes, then solving these trick codes is going to be very easy for you. Now there is a hint to solve this trick code. Uh, to solve this trick code, you should go through System Verilog Essential series, especially the two tutorials which I am suggesting is first is System Verilog regions, where we have described different regions in System Verilog in detail. This is present in System Verilog Essential series on Sweetie Speaks official YouTube channel. Then the second video which you should go through is the program block. That will help you solve this trick code. Now let's understand the code first. Here what I have done, I have taken a design module and it is very simple. There is just one output which is 8-bit address and I am assigning the value 11. Then I have the test bench top in which I am having a variable 8-bit address and I am creating a DUT instance and passing this address variable. Now, since for the DUT address is output and here I am passing this particular variable. So, whatever is the output of the DUT, since this is DUT instance, that will be assigned to this address variable. So, ideally, if you see, I am hard coding the address variable of DUT to 11. So, here, if I try to display address, it should get displayed as 11. That's what we expect. Now, what I'll do, let me run this code and see if I'm really getting 11. Because that's what I'm expecting, right? So, let's see. Alas, we got address equal to 0. How did this happen? That's why I told you to go through System Verilog region series. I'll explain you what is going on here. Now what happens is, here you are saying address assigning it to 11, but this is a non-blocking assignment. Correct? Now what happens if you go through System Verilog regions, we see that these assignments happen in what region? It happen in active region. Right now, see, if it happens in active region and by the time you display the variable, by that time if the value is not updated, you will not get the updated value. So what is happening here is actually this is executing in active region and by the time you are executing this display statement, this value is not actually updated. That's why we are seeing a race condition. We are seeing 0. Why we are seeing 0? Because it is bit. Bit for bit, the default value is 0. If you don't assign anything, you see 0. It's a 2-bit variable. If you want, in System Verilog tutorial series, I have covered 2-state variables. Bit is a 2-state variable, which means it can take only 2 states, 0 or 1. It can't take X and Z. So default value for 2-state variables is always 0. So by the time you are displaying, this value has not got assigned. That's why the default value 0 is getting displayed. Now what should be the solution for this? We have identified that this code is having a race condition. What should be the solution? For this, you should go through the program block. Program block will help in avoiding the race condition. How? The code inside the program block executes in the reactive region of System Verilog. And this reactive region is after the active region. Once active region is completed, then there is observe region, then there is reactive region. It means by the time your program block executes, all the values from the design have already stabilized. There will be no race condition. That is why we recommend to use program block here to avoid race condition. Now how to do that? Let me show you by writing a code myself. Now I want to introduce a program block here. I'll write a program block. What I'll do, how to declare a program block we have covered in System Verilog Essential series. There is a detailed video lecture on program block. So what we do, we say program and end program. This will be our program block. Now I will name the program block to some value. Say I am naming it to dut underscore program. Okay. Here I am saying input. From design, this address is output, but for this program block, it should be input. So here I am taking it as input. And next, instead of displaying here, what I'll do, I'll copy this syntax to display here. Okay. Next thing which you have to do, since this is input here, it should get input from somewhere. So what we will do here, we have taken address variable and then we have passed it to dut instance. It means whatever value 11 will come here. Now we want the same value to come to the program block. So what we will do, let me create an instance of program block. So here I have created an instance and I'll name it as tut program instance and again pass the address here. Now if you display this, if you execute this code, is this particular code, this initial block will execute and it should display the address value. Now let us try to run this code. We are getting the correct value, address equal to 11. Why did this happen? Because program block is executing in the reactive region. Reactive region is way after the active region, by the time all the design variables are stabilized. So by the time this display statement is executed in your program block, this particular value is already stabilized. That's why you will see the correct value. This is how the program block avoids race condition. I have shown you live example how the program block avoids the race condition. Now you can practice some more examples, little bit more complicated examples. With this, at least you have understood why program block avoids race condition. Understanding the concept is main, rest practice is up to you. I hope all these lectures are helping you. To stay tuned to such quality content on VLSI, please subscribe to Sweetie Speaks official YouTube channel. See you in the next video tutorial.